So we've been doing a lot of work with unfamiliar functions and graphing the key features of the unfamiliar functions. We're now going to use those key features to answer questions, especially when the problem is put into the context of a story. So for example, we're still in chapter 19C. This is page 552, number 2. A theme park water slide is constructed according to the function w of x equals blah, 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 where w is the height of the slide above the ground, x meters from the starting platform. How high is the starting platform above the ground? So the first thing to think about is what this probably looks like. And what this probably looks like is something like that. So if we were looking at this on a coordinate plane, what would you call this point up top? Well, this is your y-intercept. Since you know that's your y-intercept, you can go ahead and solve for it by plugging in 0 for x. And once you do that, you end up getting the y-intercept is equal to 12. So y-int equals 12. For part B, the water slide ends in a pool which is at ground level. How far away is the pool from the starting platform? Well, that pool is going to be down here somewhere. And if we think about this on a coordinate plane, this is our x-intercept. So what we need to do is we need to go to our calculator. We need to put the equation in so that we can find the x-intercepts. Because remember, to find x-intercepts, you plug in 0 for y, but then you have to solve it. So let's take a second to plug that in. 0.0125 caret x cubed plus 0.3x squared minus 2.35x and then plus 12. I don't know what it's going to look like, so I'm just going to I don't know where my window is set either, so I'm going to zoom 6 the first time I graph it just to get it in a standard window. So as you can see, the graph is not showing either my y-intercept or my x-intercept. So I'm going to change my window. And basically, I only need this positive quadrant. I don't need any of these negative values over here. So when I go to the window, I know that I need it to be wider, but it can start at 0 and let's say go up to 50. And just so the scale is not weird, I'll count by tens. And then my y min is never going to go below the surface. And we know that my y-intercept is 12, so this at least is going to be, I don't know, we could set it like 15. And counting by ones is fine. So now we can hit graph. All right, there we have some idea of what it looks like. 50 was probably a bit much. So if you want to smooth it out a little bit or make it look smaller, you can change your window again to I don't know, maybe 25, but that's just sort of up to you. Just you got to get it somewhere that you're comfortable. And now we're finding the x-intercept. So the x-intercept is down here, so second trace, and we're looking for the 0, so we're looking for where the graph crosses the x-intercept, which means that y would be equal to 0. And on the left side, I hit enter. And on the right side, I hit enter. And as suspected, I need to change my window so that I can see below the x-axis, which I forgot about. So let's make my y min -5. There we go. All right, try again. Second calc, 0, left side of the curve, Second calc 0. Left side of the curve, enter. Right side of the curve, enter, enter. There we go. So we know that our x-intercept is now 16. So that means that the water slide, the pool is 16 meters away from the starting platform. So back over here, pool is 16 meters away. Supporting structures hold up the water slide at the turning points of W. So if we go back to our screen, sorry, turning points are somewhere in here. And I don't know if it's going to come down and then back up or if it just kind of levels out, but let's find out. So we want how far away they are and how tall they are. So that means we need the x and y intercepts of wherever these things are. So to make it a little clearer for myself, I'm going to stretch my y coordinates out a little bit and see if I can get more information, or I can just do a zoom box. I can just zoom in to that place that I'm interested in by putting my cursor, you know, near where I want the corner to be. So hit enter there. There. So now I can see that there's a little bit of a dip here. So a little bit of a valley, a little bit of a mountain. And I can go ahead and start finding them. So we're going to do second, trace. I want to find minimums. So that's the bottom. So I need to be kind of to the left of where I think the bottom is. And then to the right of where I think the bottom is. Let's try that again. So we're quitting, second trace, second trace, minimum, so that flat bound is probably where it is, so I can hit enter there on the It doesn't make any sense. There we go. All right, so I found my minimum at 6.85 and 5.96. So that means that it is 6.85 meters from in the horizontal direction, and it is 5.96 meters tall. And then you can repeat that to find the max. So second trace. And you want the max. So that's the left side. Right side. We're guessing. There's the middle. All right, so this one is 9.15 and 6.04. So that means it's 9.15 meters from the base and 6.04 meters tall. Okay, then once you have those pieces of information, you can go ahead and sketch the graph, making sure that you have those pieces of information. So this one, we knew it kind of came down level like that, and you would want to put coordinate points there, coordinate points there, coordinates there, and coordinates there. And then that would be a good enough sketch.